Hello everybody, welcome back to another video. Today's video, this video, is about two ideas and they're called map and constrain. Mapping and constraining if you prefer. Hello, it's me, Pippin. I've changed positions. I've now got a window behind me, so I might look like a bit of a silhouette, but I am here for sure. I'm here for you. Okay, and so are map and constrain. They are also here for you. Let's jump back across to our code. I've changed our code since the previous video back to just the simple thing of a circle moving across the screen. So it's just a circle with some properties. I've got a fill property these days that's set by default to black. I guess I should actually set it to default to be 255 now that I think about it, so that it's white. I create a canvas in setup, and in draw I fill in the background color. I move the circle according to its speed. I fill the circle according to its fill, and then I draw the circle on the screen according to its X, Y, and size. And that looks like, if we head back over here, that, right? It's just a circle moving across the screen. Very nice. Like I often do, I notice that I might want that circle to start on the far of the left, so I'll set its X, the starting X that it would use, to 0. Perfect. And I'll close this window here just because it might be a little distracting. I don't know. Doesn't really change much. All right. So map and constrain. Now, a few times now I've ended up talking about this idea that numbers often come from ranges that make sense, right? So the most obvious one is that colors, the numbers that we use to control colors in P5, they're in the range of 0 to 255, right? And any number that's outside that range doesn't really make sense. So I could set, for example, the fill color of my circle to be 25,000, for example. But if I go back to the program, it's still just white because it's outside, it's way above the top of the sensible range. So 25,000 doesn't really make sense because the highest possible value is 255. And it's the same thing downwards, right? The lowest possible value for my color values is 0, so I'm giving a negative color value doesn't really make sense. Similarly, we can talk about the range of pixels across our screen. So we know that the leftmost pixel is at 0, and the rightmost pixel is at the width of the canvas. So on this canvas, that would be 500, right? It still makes sense to talk about values outside that range. Like there is the possibility that you want objects to be displayed off the screen because they might move onto it, and it might be that you want things to move off the screen, in which case they need values outside that range. But it still makes sense to talk about the width of the screen as one potential defined range. Same thing for the height, right? Along with those sorts of ranges that just sort of exist in P5 and in our understanding of programming, it's also possible that we end up wanting to invent ranges of our own, like the maximum and minimum size of the circle, or the maximum speed and the minimum speed of the circle, or those sorts of things, right? We sometimes want to control things within defined ranges. So that's another useful kind of a thing. So, one thing that we have already seen that's fun to do is to use variables or numbers from one range and apply them to another. So a classic version that we've seen of this is that if instead of setting my circle's fill to its standard fill property, I set its fill to the value inside mouse X, then I get some kind of effect out of that, right? Because I'm using one number to control something else. The mouse, which is from the range of the screen, is controlling the fill, which is from the range of 0 to 255. If we go back over, if I move my mouse around, you can see it's affecting the brightness of the circle. It's kind of coming in and out. Another thing that you can see, though, and the thing that's maybe a little irritating here, is if I move my mouse all the way to the left, the circle turns black because the mouse is close to 0, and it sets the fill to 0, and then that makes it black. But if I move my mouse around over here on the right-hand side, nothing is really changing. And that's because of this range thing, right? My mouse, when it's over here, is bigger than 255 over here, because we know that the canvas is 500 pixels wide. So when it's over here, say it's like 480. And setting the fill to 480 doesn't really do anything. It's just going to be clipped back down to 255. So because I'm just using mouse X directly, I really only have control over this color when my mouse is within the range of 0 to 255 pixels. But that's not really what I probably want to do, right? What I want probably to do is to control the color of that circle with the entire width of the canvas, or some defined range of the canvas. And to do that, we need to be able to convert from the range that mouse X comes from, which we could think of as from 0 to the width of the canvas, 0 to 500 in this case. And we want to convert that across to the range that the fill is from, which is from 0 to 255. So let's change this back and just keep circle fill as our fill. But let's look at the special, wonderful function that will let us do exactly what I was just talking about. So we want to set the circle's fill. So we're going to use assignment. We're going to say circle.fill, which is the fill property of my circle object up here. And I'm going to assign a new value to it. And the special function that we use is called map. And it works like this. First we write the name of the function, map. It's very well worth remembering because map is very neat. The first thing that we write is the number or the value that we want to convert. So the thing that we actually want to convert is the value inside mouse X. So we write mouse X there. So we want to convert whatever is in mouse X. We want to convert it from mouse X, the mouse X range, into the fill range, the 0 to 255. So after we've written the thing we want to convert, we then write the start and end range that that thing comes from, right? So mouse X comes from the range, let's say, of 0 to the width of the canvas. That's the sensible range that we can talk about the mouse existing in. You can talk about other things too, but this is a good choice. So mouse X is the thing we want to convert, and then we write the range it comes from, 0 to width. That's what it's already from. And then, as you might expect, the next and final things we write is the range that we want to convert it to, and we want to convert it to the range 0 to 255. Semicolon. So the value we want to convert, what it comes from, and then the range we would like it to be within, and then map will take this information and it will give us back a number in fill that represents mouse X controlling the range 0 to 255. So if we go look at what that looks like, now when I'm all the way to the left, it's black. When I'm all the way to the right at width, it's white, and then everything in between, right? I'll just reload. So we get much, much finer control over the color of the circle, and we see that the range that it comes from is being converted out of the mouse X 0 to width. So that's often something that we want to do, is just control one thing with another, but sometimes we need to convert between the ranges that those two things actually come from. And that is map. That is what map does, and that is how map always works. It might take a little bit of time to get your head around. The thing I think that people often find the most confusing is just remembering that this first thing is usually a variable. So we're usually wanting to convert the value inside a variable. So we normally end up with a variable here. And then just remembering that you also, when you use map, you have to put the result somewhere. And most often the easiest thing is that we're going to put it into a variable or the property of an object in this case, right? So we can do all kinds of mappings at that point. We've mapped the fill, but we can also map the size. So we could say circle.size, and we could do another mapping. We could control it with mouse Y. So let's convert the mouse Y value. We know that the mouse Y value is between 0, which is at the top of the screen, and the height. So 0 to height, that's where mouse Y sort of fits in. And I want to convert it to a size, right? Now there's no rules about what size the circle should be, so I can make this up myself. So I can decide, well, what's the smallest size of the circle I want to be? Let's say 100 is reasonable, I guess. I mean, let's make it 50. And the biggest size, when the mouse is at height, then what's the biggest size I want it to be? Let's say 500, so it would take up the whole canvas. Exactly the same principle, right? Map, the thing that we're converting now is the mouse Y value. We say the range that that mouse Y value comes from, this is between 0 and height, and then we give an arbitrary range that we've made up of the range that we want it to go to, so between 50 and 500. Importantly, for example, notice that I don't have to use 0 as the start of the range. It's arbitrary what I put in here. So then if we go look at our program again, you can see as I move my mouse up and down, the circle is getting bigger and smaller. Notice how it's getting bigger when I move the mouse downwards. That may or may not make sense. If you want to reverse that, we can write these ranges in different orders. So if I instead say that I want the mouse Y to be between height and 0, so then I'm kind of saying that height is the one that's going to map to the 50 on the other side, and 0 is the one that's going to map to the 500, then this will mean that when I move up towards 0, the size of my circle is going to move towards 500. Maybe that feels more natural. Maybe it doesn't. I mean, it's kind of up to us, right? So now as I move up, and down makes it smaller, up makes it bigger. To me, that feels sort of more natural, but it doesn't really, there's no such thing as natural, really, is there? It's all about preferences. This is quite satisfying, I've got to tell you. So that's another good use of map. The important thing there to realize is, one, these ranges that you specify don't have to be in numeric order. So we can say from height to 0 if we want to reverse the sort of effect of things. And they don't have to be a range that starts at 0. And they don't have to be based on other variables, other established variables like height, for example, or 255 for colors. We can just make up the range that we want to convert to. Wonderful. Let's do one more of these. Let's try using, instead of mouse X and mouse Y, where we're kind of using other built-in variables like mouse X and mouse Y, we could, for example, change the circle's fill based on its own position. So map the circle's X between 0 and width to 0 and 255. So the further to the right the circle itself moves, the closer it's going to get to the width, obviously, and therefore the closer its fill color is going to get to white. So it's going to fade in. It's going to start at black when it's on the far left, when its circle X position is 0, and it's going to move towards the right, which is the width, and when it gets there it's going to be 255. And map is going to map it all the way in between as well. So let's go look at that. So you can see it starts dark and then it's kind of fading in, almost feels like a sunrise, except that it's going sideways. And the sun doesn't do anything remotely like that. But apart from that, it's a lot like a sunrise. So we can also use, when we're thinking about the thing that we want to map, the value we want to map, it certainly doesn't have to be some built-in P5 variable like mouse X or mouse Y. It can be one of our own things as well. Okay, that is map. So when you're wanting to make things depend on each other, often you're going to want to map between the ranges that they come from, and that is what this specific function is for. You could do the math yourself, of course, as well, but there's no need to, and why would you do math when you don't have to do math? Okay, one last thing. I said I was going to talk about constrain, so I am going to talk about constrain. One of the things that we often want to do when we're dealing with ranges is we don't want our numbers to go outside those ranges. We want to constrain our numbers to stay within the range. So for example, if we're setting a color and it's moving up towards 255, which is white, we don't want it to then become 256, 257, and keep getting bigger and bigger and bigger. We want it to just sort of stay at 255 once it hits that, right? Similarly, the circle is moving across the screen. There it is there. It's moving across the screen. Its circle.x property is getting bigger and bigger. It's getting closer and closer to the width. It gets to the width, which is sort of the end of the screen, but then it keeps going because it doesn't care. I might want it to stop when it hits that limit of the right-hand edge of the screen. And if I want to do that, there is, again, a function that can help me with that, and it's called constrain. The biggest thing to remember about constrain is that we always use it to set our variable again. So we've just added the speed to circle X, so it's gotten bigger. And then if we want to make sure it doesn't get any bigger than the width of the screen, we can use this function called constrain. So we write constrain. Again, just like map, we give it the thing we want to apply this constraint to, which is the circle X, and we give it the range that we don't want it to be allowed outside of, which is, for the purposes of this, the size of the canvas, so between 0 and the width. So we're saying constrain circle X, which is the position of my circle, and make sure that it's within 0 in width. And what constrain will do is, if circle X is bigger than the width, it will just chop it back down to the width. If circle X is smaller than 0, it will chop it back up to be 0. But the most important thing is, well, and a very important thing, as I said, is remember that constrain gives you back the result of that constraint. So I still have to put that then back into circle X again to actually use it. If I just used constrain like this, it wouldn't actually do anything. Even though it really, really looks like it should, it won't. We have to make sure that we put it back into somewhere so that we can use it. So the result of this is that circle X is getting bigger and bigger, going from 0, it's heading towards width, it's being constrained to be within 0 and width, and that means that right at this moment where its position gets bigger than the width of the canvas, that constrain instruction is making sure that it just goes back to the width of the canvas, so it can't move anymore. It's still trying to move, so the draw loop is still happening. This line keeps happening, right? Circle X gets added, it gets speed added, which is +1, so it reaches the width of the screen, which is 500. It becomes 501 on this line, but then this line constrains it and pulls it back in within 0 to width, which means that it goes back to 500, so that when we actually draw it over here, circle X is back to 500. Okay? So it's a nice little function. It goes well with this idea of mapping as well. These are things that are about controlling the numbers in your program. And it's a great idea to maintain control over the things in your program. It makes things much more predictable. It's often really good for the people who use your program as well, because they can kind of understand what's happening a little more easily. Okay, so that is the wonders of map and constrain, two of your finest functions for use in all of your programs heretofore. Thanks for watching the video. I don't know, you had to watch the video, so I don't know if you want to be thanked, but I'm glad that you were here in the future. And I'll see you in the next video.